Hi, I'm Randy Levensalor. I'm a principal architect at Cable Labs, and I'm here today to talk to you about deploying 5G and Docsis on a shared edge platform. That means we're talking about 5G core, 5G vRAN, as well as the Docsis virtualized CMTS, all leveraging the same resources in the same location. This is part of what we're working towards with our 10G initiative across the cable industry. We're providing 10x performance and speed with increased reliability and security, as well as lower latency. On the top right of the slide, you can see some of the other technologies that we're using to deliver this. Proactive network maintenance is an application that will predict failures before they occur in your system and help mitigate them. We have new versions of Docsis, as well as coherent optical technologies to provide higher speeds. And we also have low latency Docsis, low latency mobile XHAL, and low latency Wi-Fi to reduce the end-to-end latency, both within the customer premises and in the access network. And we're very proud of this work. But one of the things, is we need to be able to deliver this quickly, reliably, and in a very efficient manner. And to do that, we're leveraging virtualization. It shouldn't come as news to anyone out there that virtualization is coming. We've started in the past with our traditional network function virtualization using VMs, and these were frequently monolithic applications that would run on commodity hardware, but largely resembled a traditional physical hardware. And we've moved today to much more of a containerized approach. We're seeing applications delivered in these scalable containers, which run on a common cluster manager or container as a service. Kubernetes is a very popular one that we're seeing used today and supported, and that's what we're using in our lab, though everything we discuss should apply to any container as a service out there today. And there's some orchestration, and we're all using shared CPUs, though this does use some custom acceleration. Think some of the FPGAs that are used inside of RUs for acceleration, as well as purpose-built IO cards. We really want to drive forward. We have kind of two major changes we're looking at doing. One is looking at how we manage this infrastructure, and we really want to treat this infrastructure as code. So we can call APIs and actually have code and software that we check in, similar to the way you develop your application. You can now develop your infrastructure, if you will. So you can check in changes, you can push these out, either install a new update or tune a parameter, and these can be applied to one or worldwide across all of your clusters. This is DevOps, maybe a term you've heard of for this, where you have development and operations working together. And we're also looking at GitOps, GIT ops, which is basing all this on source control. So you're really using your source control and approval process to drive your infrastructure. And one of these other exciting new changes we have in this infrastructure is more hardware acceleration. And this is general purpose hardware acceleration. So FPGAs and GPUs, these are mass produced, available in data center cards. And we can then offload workloads such as user plane functions for your 5G network. We can offload a lot of routing and networking capabilities. With GPUs, we can do things like cloud gaming and host all kinds of new applications, as well as run analytics or video transcoding. And all of this is managed through our infrastructure as code API. So we're able to schedule, identify failures, failover, provide upgrades, and even roll back when things don't work. So this is really, we have this great new platform we've developed, and all this platform development work has been done under our Adrenaline project. If you want to learn more information about that, please go check out openadrenaline.com. This is really where we're taking together the best of Kubernetes with additional hardware acceleration. It's all open source, even the site itself. You can provide changes, you can publish a blog if you want as well. So we really are open to collaboration across the industry with OpenAdrenaline. So we've talked a bit about the platform and 10G and kind of all these new capabilities that we need to deliver while still, reducing our impact on the environment, so reducing power consumption and reducing the space needed to deliver these services. So one of these ways we can do this is with our shared CaaS or container as a service platform. This means we're going to be deploying multiple vendors and multiple workloads on the same hardware resources. And we aren't going to have an extra virtualization layer there. We aren't going to have redundant management systems for every single application that we're deploying. We're going to have a shared orchestrator, shared scheduler, shared storage, shared service mesh, shared reporting. Again, quite a few capabilities. We have monitoring, logging, alerting are all going to be part of the shared infrastructure, which means that everyone now needs to work with these common APIs. Several of these are either provided as part of de jure or de facto standards. You can track a lot of this stuff, a lot of these applications through the Cloud Native Compute Foundation or CNCF, which is a Linux Foundation project that has participation from pretty much all industry segments. So as we look at this, there are some trade-offs and some alternatives. We do still see vendors pushing, either running their own CaaS in a virtual environment. So you're adding an extra layer of abstraction there, but you do get to share your resources. And or you can actually run a separate CaaS. So a separate Kubernetes cluster or another type of cluster on bare metal. But with that, you aren't even having shared resources. With both of these solutions, you'll actually increase your overhead. You'll have multiple layers of indirection for networking with the virtualization, with running multiple container as a services, either virtual or on bare metal. You're still reproducing a lot of those same schedulers and those same shared services. So, where you have scarce space at the edge, or you just want to be efficient with your power usage, we really want that to be consolidated and just use one shared platform. Though it does allow for each of the vendors to have exactly the version they want of their CaaS. They can have full administrative accesses to it. But again, that doesn't sound very secure to me, having requiring that level of access for every application. So this is some of the things why we've looked at using this single shared platform as opposed to doing either multiple CaaSes on virtualization or another shim layer, or just running multiple containers of service across several bare metal clusters. Again, if you really think about this from a management perspective, do you want to add even more layers of complexity to what you've deployed out there? Do you want to worry about patching, 5 versions of Kubernetes and 3 other containers of service across every head end or hub in your network? Right, that really is adding a lot of risk. You can have more security. You're not going to be expert at any one of those containers of service platforms, as opposed to if you're running a single infrastructure across your node or having another service, having a managed provider run those for you. So let's talk a little bit about the applications that we're running. So for Docsis Virtualization, right now we're focused a lot on the remote PHY architecture, where we have a CCAP core and other components such as timing and other cores running on virtualization here on the left side of the screen. And then you have a remote PHY device connected over Ethernet, and that can either be in a shelf in the head end or deployed in a node in the field. Going forward, we'll be looking at our flexible MAC architecture. This is a specification that's already been released, and we do have vendors supporting this. So we'll be able to have more flexibility in where we place things within the network. We can go with a remote PHY device, or we can go with a remote MAC device, which actually adds some of the MAC layer out into the node. And you can even implement that by running virtualization and actually having that node be a part of your cluster that's in your head end. Again, more flexibility, more decomposition, things that you expect as your virtual options mature, and you get more scaling and more redundancy with this model. So again, right now we're looking at just deploying a simple CCAP core or within the head end, and then having a remote PHY device to manage the PHY layer. For mobile and 5G, we're running both the 5G core and the vRAN. VRAN is something obvious to run at the edge or in a node. We know the RU, DU, CU, and then looking at VRAN, at ORAN, we can run our RIC and some other applications as well to provide some additional management and interoperability within that radio access network. And then the core, now this could be run centrally, it could be run in the cloud. Some of the functions like the user plane functions, these actually make sense to have a local breakout, because the sooner you can get to your data network, you can access, caching or access other edge applications. So we do like the notion of having the UPF very close to the edge. And there are some use cases where you'll want to actually have a standalone core for a network slice that's self-contained at the edge, or perhaps hosting a private LTE network for a corporate campus or a stadium. So again, these are our two of the primary applications we're looking at deploying today together. With our core and RAN, we have multiple vendor options, as well as with our CMTS, we have multiple vendors that are providing. So we're not just running one instance from one vendor, we're running multiple instances from multiple vendors, all on the same cluster. I know you're thinking we're crazy, but it works. Generally speaking, there are some challenges when we are working closely with the vendors to get this going, both the infrastructure vendors as well as the application vendors in these spaces. So I mentioned there are some challenges, right? And today, a lot of the applications are developed on a specific flavor of CAS. So that could be, VMware's Tenzen or OpenShift or Rancher, or very frequently it's their own version based on the upstream open source Kubernetes. And while these are all Kubernetes, they all support the Kubernetes APIs. There are subtle differences in the way security is managed. Some of the networking components can provide different interfaces and different capabilities. So getting everyone on just to be portable to support any, again, we feel that the container as a service should be selected by the service provider, not the vendor. Because if you start talking to the vendors, you'll end up with 8 different container as a service options. And you really want one that it's the best for that service provider, whether it's a open source one with support, a proprietary one, or a pure open source one that is actually run and maintained by that service provider. So again, working with the vendors to help increase the portability of their applications between these different services, these different flavors of CAS. Another is just supporting the current release. With Kubernetes, there are APIs that do get deprecated. So sometimes things need to be changed between releases. You do have a year notice or more that an API is going to be deprecated, but sometimes that still takes time and you may be focusing on another customer deliverable or something. So it doesn't always get prioritized. Other challenges are with the different flavors is they may actually change some of their components as well. So that's another thing. And this is, again, something that we're trying to facilitate, right? How can we test multiple versions at once? There are services out there, and this is something, again, we're happy to work, and we are working with both vendors and for the applications and the infrastructure software to do that. Next is most of these installers are actually assuming cluster administrative privileges, which is nice because, at first blush, right, you can actually stand up your cluster, you can create all of your namespaces, you can create your interfaces directly to the network, and all these things that actually require full access to the cluster. However, if you start having 2 competing vendors running on the same cluster, you clearly don't want vendor A and vendor B to either be able to do something malicious or maybe even find out some information that's proprietary. So we're working with these vendors to separate the cluster administrative work so that way the cluster level administration tools are things that we can apply and manage through our orchestration tool. We're using Argo CD as a GetOps to apply these to the cluster, but you can use another orchestration tool as well. But we're basically, anything that's cluster level, we want to be able to review it and manage it ourselves. We don't want to leave that for the vendor-specific automation tools. So that's one thing, and it's, again, it's more of an install process than a runtime challenge. So we're working on that and really working on improving that. Next, is there certain cluster-wide services? We mentioned the benefit that you can share logging, share persistent storage, share monitoring, share your service mesh, which is kind of a way of load balancing your applications. However, a lot of these are cluster-wide, so you need everyone to work on the same version. There are ways to do plugins for most of these that can be limited to the namespace or the namespaces for that application. But in the end, it still relies on that same common service. And that's something, again, it's just a little bit of work to do. We're making progress there. Conflicting node configurations. We're talking about very high performance applications here with low latency, especially if you start looking at the RAN and some of the data layer for Docsis. We don't want to add any extra latency. No one wants an extra 10 milliseconds of latency because you're going through 3 layers of abstraction or you don't have your system tuned. So we're working to, how do we tune things like huge pages, which is having large segments of contiguous memory that makes things work faster, or even looking at queue and process sizes. So trying to come up with, what is a standard set of configuration options so you can use these across multiple vendor sites with the same physical server configuration. Once we get through this a little further, we'll probably publish a lot of these very specific tunables on the Adrenaline project page. And there's just general fear of, well, there's another application, I don't know what it's doing. It may interfere with the core application. So again, we're really looking to get away from that. I think a lot of that is fear. There are instances where that happens. And the answer shouldn't be, we're just going to separate and run on dedicated hardware. It should be, we're going to figure out, what do we need to do that there? Do we need to put hints in the scheduler? Do we need to add additional constraints? Do we need to reserve resources, either networking, memory, CPU, for an application to avoid that? So there are quite a few tools in that toolbox, and we're working on those, and we'll demonstrate those. And then finally, a lot of things are tested on a very specific hardware model where, a vendor's assuming that they're able to offload on a very specific version of a network adapter or specific generation CPU. And, especially with these supply chain issues today, you may not have the same hardware available in every site. And as new hardware comes available, it's more efficient on power and faster. So you really want to be able to take advantage of that. So in summary, you can really look at leveraging a shared CAS platform for edge deployments. It is going to provide some initial integration challenges, but we find that vendors are willing to work with us on that, both the infrastructure and the application vendors. And this is an ongoing process, but I think once we get through those initial integration points, it'll actually provide for a much lower cost, more efficient, and more streamlined deployment across your entire network. Again, with Edge, you're not deploying to 1 or 2 data centers. Depending on your size, you can be deploying to tens, hundreds, or even thousands of edge locations. Thank you for your time.